Hello everyone. In today's session we will discuss about white box testing. First we will see the definition of white box testing. White box testing is a way of testing the external functionality of the code by examining and testing the program code that realizes the external functionality. This is also called as the clear box testing or glass box testing or open box testing. White box testing takes into account the program code, code structure, and internal design flow. Here we are mainly concentrating on the code of the program. Next, we will see the classification of the white box testing. White box testing is divided as two parts. One is static testing and another is structural testing. Again, static testing is divided as three parts: desk checking, code walkthrough, and code inspection. And structural testing is divided as three types: unit or code functional testing, code coverage, and code complexity. Now, first we will see what is meant by static testing. See here, static testing is a type of testing which requires only the source code of the product, not the binaries or executables. Static testing does not involve executing the programs on computers, but it involves selecting people going through the code to find out whether the code works according to the functional requirements, or the code has been written according to the design, or the code for any functionality has been missed out, or the code handles errors properly. Static testing can be done by humans or with the help of the specialized tools. There are multiple methods to achieve the static testing by humans, and they are desk checking, code walking. First we will see what is meant by static testing. Okay, first we will see the static. Within the statics testing, first we will see the desk checking. This is normally done manually by the author of the code. Desk checking is a method to verify the portions of the code for correctness. This can be done by the programmers before compiling and executing the code or program. Whenever errors are found, the author applies the correctness for errors on the spot. This method of catching and correcting errors is categorized by two methods. For the first one is, here there is no structured method to ensure completeness. In the desk checking, we are not following any structured method. And the second point is, here we are not going to maintain any log or checklist. Now we will see what is the code walkthrough. Code walkthrough. In code walkthrough, it is a group oriented method. Here in code walkthrough, a set of people look at a program code and raise the questions for the author. The author explains the logic of the code and answers the questions. If the author is unable to answer some questions, he will take those questions and finds the answer for those questions. Completeness is limited to the area where questions are raised by the team. The advantage is that it brings multiple perspectives. Now we will see the third one, that is code inspection. Code inspection. Code inspection is also called as formal inspection, or it is also called as Fagan inspection. The focus of this method is to detect all faults, violations, and other side effects. This method increases the number of defects detected by thorough preparation before an inspection, analyzing multiple devices, assigning specific roles to the multiple participants, going sequentially through the code in a structured manner. In a formal inspection, there are four roles. The first role is the author, and the second role is the moderator, and the third is the scribe. Here, first is the author of the code, means who is going to write the program, or the programmer itself is the author of the code. Second is a moderator, who is expected to formally run the inspection according to the process. Third are the inspectors. These are the people who actually provides review comments for the code. There are multiple inspectors. Fourth and finally, there is a scribe who takes detailed notes during the inspection meeting and circulates them to the inspection team after the meeting. This is about static testing. Static testing contains three different types, that is desk checking, code walkthrough and code inspection. Desk checking is a single person oriented, code walkthrough and code inspection is a group oriented methods. Now we will see the structural testing. With this we will see what is meant by structural testing. Structural testing takes into account the code structure, internal design and how they are coded. Structural testing contains running the actual product against some pre-designed test cases. The main difference in between structural testing and static testing is that in structural testing, tests are actually run by the computer on the built product, whereas in static testing, the product is tested by humans using the source code and not the executables and binaries. See here in structural testing, we are going to execute the program code, that is after running the program code to test. In static testing, we are not executing the program. The human beings are going to test the product, that is the static testing. Static testing is again divided as three types. The first is unique or code functional testing. Second one is code coverage testing and the third one is code complexity testing. Now we will see the first one, that is unit or code functional testing. See here, this is the initial part of the testing, that is structural testing. It corresponds to some quick checks that a developer performs. These quick checks can be done with several methods. The first method is initially the developer can perform certain obvious tests knowing the input variables and the expected output variables. This can be a quick test that checks out any mistakes. Now, the second method is for modules with complex logic or conditions, the developer can build a debug version of the product by putting intermediate print statements and making sure the program is passing through the right loops and the iterations and the number of times. The third method is by using the debugger, that is IDE, that is integrated development environment. Here we are going to do the initial test. This is used to run the product under a debugger or an IDE. Here we are going to set the breakpoints in a program. Here we can set at any function and we will verify the program parameters or program variable with the help of the IDE. By using these three methods, we can do the unit or code functional testing. We will see the code coverage. First, we will see what is meant by code coverage testing. Code coverage testing involves designing and executing test cases and finding out the percentage of code that is covered by the tester. The percentage of code covered by a tester is found by adopting a new technique called as instrumentation of code. See here in code coverage testing, we are finding out the percentage of the code covered by a test. And here we are finding this by using one technique called by the instrumentation of the code. Here code coverage testing is made up of four types: the statement coverage, path coverage, condition coverage and the function coverage. First we will see what is meant by statement coverage. Statement coverage refers to writing test cases that execute each of the program statements. There are different types of program statements, that is sequential control flow statements, two-way decision statements like if then else statements, multi-way decision statements like switch statements, Loops like do loops, while loops, repeat until, and for loops. Here, one can start with the assumption that more the code covered, the better is the testing of the functionality. Based on this assumption, code coverage can be achieved by providing coverage to each of different types of statements like sequential control flow, two-way decision statements, multi-way decision statements, and loops. The formula for statement coverage is total statements exercised divided by total number of statements in the program into 100. This is the formula for calculating the percentage of the statements covered in a program. Next, we will see the path coverage. In path coverage, we will split a program into a number of distinct paths. A program can start from the beginning and take any number of paths to its completion. Take the example, let us take an example of date validation routine. A date validation routine. Here, the date is accepted as three fields. First is month in terms of next is date in terms of DD, and year in terms of YY. And the formula for path coverage is total paths exercised divided by total number of paths in a program into 100. This is the formula for calculating the percentage of the path coverage. We will see the example, that is the date validation routine. See the flow chart. This is the flow chart for date validation routine. See here, we are denoting the different paths with the alphabet, that is A, B, C, D, E, F, G, H, and used. These alphabets are used to denote the different paths. See here, we need to analyze how many paths are there to reach till the end. According to this, here we are validating the date, whether the given date is valid or not. According to this example, we can find out the many paths. The first one is A, the second one is B to D, D to G, third one is B to D, D to H, fourth one is B to C, C to E, E to G, and the fifth one is B to C, C to E, E to H, and next sixth one is B to C, C to F, and F to G, and the last one is B to C, B, F, and H. We will see that one. The first one is A. See here. Here we are going to check whether the month is less than 1 or it is greater than 12. If it is true, then it is a invalid date. Here month is less than 1, and if it is greater than 12, then it is a invalid date. Here we are going to come out. If it is a false, we are going to check the second condition, that is whether the month is equals to 2, that is whether the month is February. If it is true, we are going to check whether it is a leap year or it is not a leap year. If it is false, means we are coming out of this one, and here we are going to check whether date is less than days of month or it is greater than days of month. If it is true, it is an invalid date. If it is false, it is a valid date. See here, if it is a leap year, we are going to, if it is a leap year, then if it's true, then the days are 29. If it is false, the days are 28. Like this is a date validation routine. To reach end, there are many paths: A, B, C, D, E, F, G, and H. To reach till H, how many paths are existed? Total 7 paths are existed. Like this, we are going to test the path coverage of a program. We will see the next one, that is the condition coverage. In the condition coverage, it is necessary to have the test cases that exercises each Boolean expression. Here we are going to check the Boolean expression and have test cases that produce the true as well as the false paths. Obviously, this will increase test cases exponentially with the number of test number of conditions, and Boolean expressions. The condition coverage is defined by the formula, that is condition coverage equals to total decisions exercised divided by total number of decisions in the program into 100. This is the formula to calculate the condition coverage. Here it is used to indicate the percentage of the conditions covered by a set of test cases. Condition coverage is much stronger criteria than the path coverage and the last one is function coverage. See here what is meant by function coverage. It is used to identify how many program functions are covered by test cases. Test cases can be written to exercise each of the different functions in the code. The advantage of the function coverage provides over the other types of the coverage, that is statement coverage, path coverage, and the condition coverage. What are the advantages? We will see the first advantage is functions are easier to identify in a program, and therefore it is easier to write test cases to provide function coverage. Second advantage is functions are at a higher level of abstraction than the code. Therefore, it is easier to achieve 100% coverage. And the third one is functions have more logical mapping to requirements and hence can provide more direct correlation to the test coverage of the product. And the fourth one is function coverage provides a natural transition to black box testing. These are the advantages of the function coverage. We can measure how many functions are covered in the program by using the formula, that is function coverage equals to total number of functions exercised divided by total number of functions in the program into 100. This is the formula for calculating the percentage of the function coverage. And the next one is code complexity testing. This we will cover in the next